In this video, I'll show you a few more ellipse drawing methods and also how to draw circles in perspective. And it's all in my book, Ellen's Guide to Perspective, on Amazon. In the last video, I discussed drawing ellipses, but I have a few more methods I want to show you, which I think might be useful to you. This one I like because it's getting an ellipse into a trapezoid, which is a very useful thing to do. And if you look here, you can see without help, it would be difficult to know exactly where to put that ellipse. So we start with a symmetrical trapezoid and find the midpoints of the beginning, the near side and the far side. And then draw black lines from the corner to the midpoint, back to the corner. Again, over here, corner to midpoint back to the corner. Then you draw this blue line through these intersections and divide the near side here in half and the far side in half. And then draw these green lines as I show you. And the points for the ellipse lie where these green and black lines intersect. Here's a point on the ellipse, here's another point, and so on. And you connect those points and then you can get the ellipse in this trapezoid. Another useful technique is if you have a partial arc, how do you make it into a total ellipse in a trapezoid? So you find the points on the diagonals of the trapezoid and you draw converging lines that converge to the same vanishing points as the sides of the trapezoid. And when you reach the other diagonal, that will be a point on the full ellipse. And then if you draw a line down, you will find another point on the other diagonal, which will also be on this ellipse. This method uses two concentric circles, and the resulting ellipse lies inside one of the circles and outside the other. The major axis of this ellipse that we're going to get is as long as the diameter of the big circle. The minor axis of this ellipse is as long as the diameter of the small circle. So what you do is you draw a radius that goes from the center to the edge of the large circle, and then draw either vertical lines up or down from a point on the large circle. Then, where this radius hits the small circle, you draw horizontal lines. And over here is a blow up. You can see the vertical line from the large circle, the horizontal line from the little circle meets at this green dot, which would be on the ellipse, a point on the ellipse. So if you did it the other way around, for example, if you did horizontal lines from the large circle and vertical lines from the small circle, you would get an ellipse that's perpendicular to this one. I'm going to show you two ways of going from a circle in a square to find an ellipse in a trapezoid. In this first method, you divide the box into a 4x4 grid and then draw these four X's that go on the outside of the grid. You can see, and there's an X here and then the final X over here. Now the question is, where are the points on the circle? So you follow one of these red lines toward a corner, and when it crosses a green line, that will be a point on the circle. Over here is a red line. If we go this way, it's not going to help us. This green dot is not from this red line. We have to go this way to find this green dot that's a point on the circle. What about this line over here? This way is no good. We have to go toward the corner to find this green dot that's on this green line. Once we have this pattern, then we can use converging lines and find the same pattern on the trapezoid to find the ellipse inside. Another way of doing it is to divide this area into 6 parts. And the beauty of that is that line 1, this blue line here, and line 5 hit the diagonal right where the circle hits the diagonal. So that immediately gives us 4 points on the circle. Then these lines converge toward the center of vision, and where they cross the green diagonals would be points on the ellipse. Now the question is, where do we put these green diagonal vanishing points? Well, you would have to set up the eye, and at the eye, the angle is always 90 degrees, and it is directly below the center of vision. We're dividing this angle into two 45-degree angles, and when you extend that to the to eye level, you get this vanishing point and this other 45-degree vanishing point. And then you can do the same. You can draw these lines to the diagonal, and where they cross the blue converging lines would be points on the ellipse. Now, I did the same thing here by just superimposing the eye, which you can see here, on everything that I did over here. In my next video, I'll talk all about cones, and you don't want to miss it. And please remember to subscribe.